Hi, I'm Sportster Paul. We're here with the fourth impression of BobCAD CAM. Last episode we got the whole top done, but there was a little problem. We left a little gouge on the slopes that we did. I used advanced, I think Z level. So I've been playing around a little and it looks like I can fix that. Let's go up and check the Solidworks here. This is the last one, the way we left it, and it's got this curlicue right here. And I couldn't get rid, the toolpath wants to come down, you say go parallel, it comes from inside the part. All these CAM programs seem to love to carve up your part. So I thought I'd play around with some different ones. This is part number 3, let's go. Okay, so this is what I ended up doing. So this is advanced, let's go look at slopes, edit. Advanced planar. I think I tried planar. The machining. Here's all the strategies that you can do. I gotta admit, it's pretty impressive. I assume this is just with the 3D version. You gotta pay more to get all this good stuff. Last time I used advanced Z-level finish, and that's what put that weird curlicue and gouged the part. Tiny little gouge, but it's still not right. Then I tried, I think, just regular planar. And that went all the way across the gap. There's slowly machining in the air. All these CAM programs love to machine air and the solid model. Okay, that was close, but it wouldn't go down. Here, let me show you. There were 3 problems, okay? The gouge is the third. The second problem was it would leave material along this angle. All the programs have been doing that. Something to do with the math about this is not a rectangular patch. It's a trapezoid. So the tool pulls up a little. I fixed that with 3D extents on this, on that Z level one too. So it goes a little further here, and the other problem is it wouldn't go down low enough. The ball mill wouldn't come down to this face. It would take this mathematical surface, go straight up and stop the center of the ball mill there and leave a bigger scallop. So with this advanced planar, I believe it is, you can see there's no funny curlicue. It's not going all the way across like planar was that seemed to be wasting a lot of time. Maybe that's why it's advanced. I assume it comes in a 3D package or a more expensive package, worth every penny in my book. What do you want to do? We can go real quick and next stop. Turn off toolpaths. Always turn off those toolpaths for me. There's a perimeter. Here's a rough pocket, finish pocket, shallow finish. Then the rough flat, finish the flat, and get used to the things I don't like about SolidWorks is this simulator for a couple reasons. It's not as, it doesn't color code and do things like Visual Mill or SolidWorks CAM by CamWorks. But the buttons work different. And you think that's silly. Well, it's the index finger that rolls it around instead of the middle. It's extremely frustrating because you're jumping back and forth. Maybe there's a way to set them different. That'll be a fun project. I'll look at that. Okay, so we're kind of reasonably fast. Let's go run. Here comes our ball mills. I'm surprised that advanced Z level generated right about here. It generated a crash. It didn't like something that ran into the toolpath. This one seems to be smart enough. I didn't have to fix anything. You could see those earlier toolpaths. I went way up high just to make sure. And here's the little one. It's staying in the meat, right? It's not wasting time going all the way across like the regular planar was. So I'm really excited by this. This is a big deal. It's doing the bottom now. We can go look here. You can see there's a tiny little scallop, much smaller than before, and there's not a ton of material down on this edge where the ball mill would pick up a little quick. Kind of see that. See, it's much more accurate. And I'd like, this is where I'd love to have that color coding to say, okay, are there some thousands? What's the error bands in color encoded on the part? That would be my biggest wish. That you can define the buttons to work like SolidCAD or SolidCAD, like SolidWorks. So we'll stop it. It's doing the bottom. That's today's show. We're going to finish this part. It's kind of exciting. So slopes, let's hide is blank unblank. Programmers always come up with their own jargon. So on the bottom, save a little time. Okay, now we're in SolidWorks, and the middle button is what does this. I went and I defined, I think you have to define part 0 now somewhere on the part. I said, well, down in this corner, I could find the parallel and the vise and put a part stop, because otherwise you can't go to the top of the stock like we did to begin. I'm pretty sure I'd have to run it by my machinist pals, because the thickness of the stock is going to change how big the part is, right? All it knows is here's 0 and I'm going to go down so far. And so you can't count on the stock being exactly the same. You shouldn't, right? To make this part accurate, you want to reference part 0 on the flip side now, down here. And that was fairly straightforward. No, that's stock. We don't need that. Bottom setup. Going edit. You know, picking origins. Doing stuff like that. Offsets, all that good stuff. Let's get out of here. So that was straightforward. Facing was just as straightforward as before. The secret is, oh, it's not going to do it now. When it asks for geometry, you don't tell it anything. MasterCam works like this. I think this is where everybody got the idea. A lot of these programs, you just say, nope, I'm not going to select anything because you're the computer and you're supposed to be smart. So you figure out how, you know, where the stock is and how far down. What I did wrong, it had a 1/4 inch 2 flute end mill, and longer one, although it doesn't have to be long now. I figure the whole point is to keep one tool in here. I said zigzag, not the end of the world. Maybe you just want to climb or go one direction. Here's where it defaulted to doing 4/10 of an inch in, you know, passes. And I said, well, let's go multiple depths. Let's only go down 100 thousandths so that it'll do 1/10 of an inch on each whack. That little, I didn't have to mess with this other stuff. Compute. It's unblank. Unblank. There we go. So there it is. It's doing what we want, right? Going down through the stock. So we can hide the stock again. I'm getting to like BobCAT. I really am. Just the simulator and the way the buttons work in the simulator is driving me nuts. So I'm not even going to simulate it. I mean, it was a simulation, as much as I don't like the simulator, that said, oh yeah, it's taking all 4/10 and, you know, okay, let's just jump real back, stop it short, jump real back, fix it. Okay, so now we're almost done with this part, right? This is a big deal. Let's hide this, blank. If it will let me, am I in the middle of something? Blank, unbanked toolpaths, okay. Maybe a mouse error. So because we're highlighted there, you know, that's why the purple shows up. So now we want to do these 5 tapped holes. I am going to do insert mill tap hole. It wants geometry. So the first thing I did is say, well, let's do, I think, like visual mill. And you say, hey, that face, it's got 5 holes in it. It hasn't selected anything. Duh. So go back to select geometry. Said, well, let's do the sides of the holes, then it'll know how deep it is, right? Being a smart thing. Notice now it's broken it up into through holes and non-through holes. So that's kind of a pain. The first time I dealt with this in the many rehearsals I've been doing, I said, well, let's just do them all individually. This is pretty sophisticated. I got to admit, you can learn to love. It'll center drill it, then drill it, 201.201, which is the tap drill size for a 1/4 20. Then it'll chamfer it, run a little chamfer there to put a nice little slope. Then it'll run the tap in. Now, my avid benchtop pro isn't going to do rigid tapping, no encoder on the spindle. But I figure that might interest you. Obviously, I would take the tapping operation off. Can you unselect this? Select geometry. Let's do it this way. No. Oh, okay, here's where you put them all in. Right over here. How sweet. So clear selections. And I don't know that there's an order, but just select the ring, right? It won't have depth information now. It won't distinguish between which holes, and they're all the same holes, same depth. It's just some of them happen to break out, right? They're all 0.38 deep, as my buddy Dave, the mechanical engineer who made this part. See, now they're all in one group. It thinks they're all through holes, and it wants to go 1.5 inches deep. I don't know why it picked 1.5 inches. It just likes that number. But we know 0. Were you taught to put leading zeros? I was 0.38. And we'll go next. And it's pretty sweet. Does the center drill. You know, you can define the tool here. Does the drill, longer, shorter, anything. But, you know, right diameter. It knew that just from it's a 1/4 and it's modeled. It's a 0.201. Chamfer uses this tool. Probably don't even have it, but it's good to know it's there. They picked all these tools. And the 1/4 tap. This one dimension, see, this is where I'd be very worried about, you know, not having a great simulator to show this one right here, ineffective number of threads. I guess you can go like that. You can make it blunter, like what is it? There's tapping, then plug, then bottoming. Those are the 3 kind of taps: regular, plug, and bottoming, if I remember right. So depending on those blind holes and why, you know, this is just the fun part. It doesn't do anything. It was just made to put these CAM packages through their paces. So this is something I'd worry about. Well, are they going to the tip? Are they going to go too far? Do they define the drill by the tip of the drill as 0.38? Then it won't be deep enough, because that's not the way Solidworks works. I think it goes by the flank of the cylinder, not the little extension of the 118-degree tip. That would be interesting. Let's see if the system tool, there should be some tool label. Yeah, look at that, 118 degrees. So unlike Visual Mill, I think picked 120. This one even has a good thing there. So we fixed the depth. I think we can just say compute. Let's save it. Thank you so much, BobCAD, for letting us save this demo program. It won't open in your paid-for version. And it's doing them in a sensible order. This is the problem I've had with all these programs. You know, you let SolidWorks CAM by CamWorks, automatic feature recognition. Well, it wants to do 2 holes from the top, 3 holes from the bottom. When obviously, you know, not artificial intelligence, but average person would say, oh no, you do all 5, same depth, same everything. Even when I flipped it over, it still wanted to break it into 2 groups. So this is a kind of way to get around it. If you select the faces, it'll get you, you know, it's trying to help you too much. This way you got to know the depths and type it by hand, but it works. So we saved, we can simulate. I think the simulator goes through the whole, you know me, I don't like toolpaths to be visible. Next stop, yeah. There's perimeter, here comes the pocket, finish the pocket, the shallow pocket, finish that, whack the big meat off the flat, that was the finish. Here comes our, do you want to watch that? I guess we can do this. The zoom wheel's backwards because I reversed it on SolidWorks to be like my TurboCAD. The left finger is roll it around instead of the middle. Pan is just the right finger, which is very convenient. I prefer it to SolidWorks. It's different, and you go nuts switching between the two. I'll have to look. SolidWorks, since it let me reverse the wheel, maybe it'll let you redefine the buttons. Pretty sad, though, to use the High-Zoot SolidWorks. That's pretty good, right? Okay, we'll speed it up. Speed it up a little more. Speed it up. And these are those 10th-inch whacks. Of course, it wears the tool out because you're just using that very tip of the tool. So that's a shame, but this is the drama because it's the end of the part. 15 minutes into the show. Hooray, we're ahead of schedule. And then first, another mistake I made, it had the ball mill left in it from when it did the slope. I didn't read it carefully enough. So the first time I simulated this, it's like, why has it got a ball mill? Bam, that was it. That was done, right? So here's our part. It's, like I say, the simulator has these funny colored patches here. Is that something real? I think it's just rounding error, just mathematics. What really worries me, like here, is that the difference between the finish pass and the roughing pass makes it those two different colors. Let's do the, see with SolidWorks CAM and Visual Mill, you just say compare, and then you get a color-coded report. This one, you say verification, gouge excess, it thinks, it looks all over the thing. Show gouges, there's no excess anymore, like it was before. For the first time, we've got gouges, and as you'd expect, if I could use this darn, the gouges are where the holes are, right? This is the same problem in that the tap is defined as 0.25 outer diameter. The holes are 0.201, so that's the drill, the tap drill size. So as far as the program's concerned, is like, hey, you gouge through that model, because the model was 0.201, but when we simulate our tap, we use the outer diameter of the tap. All the programs have been doing this. You kind of expect it. You don't get too worried. It doesn't show excess material anywhere else. So that's a win in my book. I guess as you get more and more confident, the simulator not being super cool doesn't bother people. It's making pretty good toolpaths. So as you'd expect, it's a very popular program compared to SolidWorks CAM and Visual Mill. But like I say, I'll have to see if there's some way to redefine the buttons. That'll be my homework for next show. Get out of the simulator. So that little trick with the drilled holes worked out pretty good. I think you can show everything, blank everything. Show everything, there's all the toolpaths. Oh, see, now I'm using the left-hand button because I was in that simulator. It's so, I don't think they understand how exasperating it is. And I'm sure this is the way standalone BobCAD works. So there it is. All right, I'm pretty happy. We're gonna, instead of running long like always, we finished the part. Came out pretty good. BobCAD is the only program so far that's been stable. Well, I shouldn't say that. I've been playing with Mastercam, getting ready for the next batch of shows, and it's been okay. Very bloated, very big, but it's been at least stable. SolidWorks CAM by CamWorks, if I close the dialog box on this middle screen, it poofs away and I can't get it back until I use screen resolution and move my monitor to non-existent places till I find that dialog box and then drag it. If I close it on this other monitor on my other side, well, then it reappears on that other monitor, but not on the main monitor. You can go in the registry and fix and have it start all over again. You erase this dialogues key and it puts the dialog boxes back where they are, but that doesn't matter. You'll find them again if you can't find them moving screen resolution around. But it'll still, if they're on this main monitor, they'll poof away and disappear. Visual Mill, because they had that installation issue, I assume, it didn't, it said, oh, you've got a newer version of C++, Microsoft Visual C++. So we're not going to install the older version. You think that would be okay. But it was changing dialog box values. It would put a 1. Anytime I'd set the stock allowance to 0, go back and forth between two tabs, it turns into 1 inch. So that kept blowing up. If I said a 0 size finish cut, it would bomb a toolpath like 2 feet down through the part. Is that because it's an old Windows 7 box? I got a goofy video system with a half Intel, half Quadro, NVIDIA Quadro. I'm coming DisplayPort out of the side of the computer for the four monitors, right? I'll show you that setup, right? This is what I've been working on. So when I'm doing it for you, I shrink everything down and work inside this smaller box. But usually I can have SolidWorks spread out over 2 full monitors, all the files on Free Commander over on the right, and up on the top usually is a browser Firefox where I'm looking up YouTube videos to see how people do stuff when I get, not so much for this. All this stuff has been intuitive. It's only been Mastercam where I've had to give up trying to figure it out and go dig into tutorials to get started. So meanwhile, we're happy with BobCAD CAM. I think that's the right name for it. I don't think it's BobCAM. I think it's BobCAD CAM. And cutting good toolpaths looks pretty nice and not as expensive as some of these other packages and gets you into 3D. And their 3D did some wonderful stuff here. All right, so we'll see you next time. We'll have more fun stuff for you in the CAM world. Bye now.